Alrighty, we finally made it to our first milestone project. Give yourself a pat on the back. We're going to be making a random number guessing game in this video. I'm thinking I'm going to divide it up into two parts. So this will be part one. Uh, Essentially, we're going to be generating a random number 1 through 50 at the beginning of the program and let the user input their guess. If the guess is too high or low, we're going to notify that the guess was either too high or low and let them keep guessing until they get it right. Huzzah! If you want to follow along, then go ahead and create a new project with cargo new guessing game. And then make sure your editor's all fired up and ready to go and go into your guessing game directory. We're going to first visit cargo.toml because we're going to be utilizing the rand crate for random number generation. So in order to make this crate available to our project, we're going to include rand equals, and we're using this specific version of the random crate. That's all we need to do here. So I'll go ahead and close out of cargo.toml and then go into our main.rs. And we're not saying hello world anymore. We're going to be saying guess the number. And we're also going to prompt the user for their guess. We're also going to start introducing the idea of ownership. So far with everything we've done, we have worked on the stack. Types like integers, booleans, and floats don't need pointers or references because we copy them when passing them as parameters and returning them from functions. So you're pretty familiar. I'll just go down here. This is gonna not part of the game, just demonstration. So we could say, of course, we're pretty used to this, let x equals 5, and then we could do let y equals x. And both our x and y are valid, and they're going to equal 5. And we could also do something like y plus 3 plus equals 3 if it's mutable. And x is going to equal 5, and then y will equal 8 in this place, or in this case. So if I go ahead and cd into guessing game, and then run this program, you can see 5 and 8 makes sense at this point. So great, this should make sense, right? So far what we've done with strings at this point, what we know is, well, we've passed them into println. Now, you might be thinking in order to allocate memory for a string, you do something like let my str equal hello world, and that's a string. Technically, yeah, this is a sequence of bytes in memory that make up a string, but it's not mutable. When we use double quotes in Rust in a program, we're basically saying, okay, we want this to be baked into the data section of our program where memory is not mutable at all. So this is an immutable reference to hello world. Now we can't do something like this, like let mute my str equal hello world, and then maybe add to my str plus equals hi again. This we can't do because, again, this is in read-only memory of, or read-only region of memory when we hard-code strings. And this is called a string slice. A string slice is type, as you can see in my little tooltip here, is type str, so that's the same as annotating at str, or ampersand str, and the ampersand is basically saying, okay, this is a reference. This isn't the value itself. So coming from languages like C or C++, this is basically saying it's a pointer, reference, same thing. So we're getting a pointer to this hard-coded value in memory, which when it's compiled to its binary actually lives all the way up here. So somewhere in data section we have hello world, rest of our binary down here. And this mystr is getting a reference to the hello world that has been compiled to be up here in our data section of our program. And again, these string slices, they do point to hello world, but they also say how many bytes should make up this string slice. Makes sense. It's a slice of a string, right? So this is the same as saying my str points to some area in memory, 0x1234, and then with length of, that'd be 0, 1, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, because those are all ASCII 12 bytes. Do know that when you're working with strings in Rust, if you do 0, you're getting the 0th byte, not the 0th character or the first character. That's just something to take into consideration. And by default, Rust works with UTF-8, so if you had like an emoji character or something that's not ASCII, it might be like half of a character you'd be getting within the first byte. So just something to keep in mind. So great, we have immutable references to strings, or we have these hard-baked strings in here. What if we want to do something like this? I'll go ahead and save and just prove my point that, again, not allowed. But what if we want to modify a string? Luckily, the Rust standard library provides this to us, or it's actually in the prelude, I should say. And I'll go ahead and declare a string instance as opposed to a string type, or excuse me, a string slice. I'll define a string instance by doing my str equals string new. And this creates a string instance based off of a string struct. Structs are kind of like vaguely like classes if you're coming from another language. So we just created a new instance of string, and this lives on the heap now. We're no longer dealing with stack-based operations. So now we have a pointer, or we have ownership, yes. And we're gonna get into ownership in a second, but basically we're saying my str now points to this new place on the heap that has this empty string. And now I'm able to do my str plus equals hi. And I can go ahead and debug our my str. Hi. And again, we just modified our string here. But we're more interested in getting a guess rather than playing around with strings, right? So we're going to keep the MUT keyword because even though we're not changing what mystr points to, we are changing the value of what is in mystr, which Rust cares about very deeply. So I'll go ahead and just call this our user guess. Guess equals, again, string, and we're making a new string. And let's create our random number, and we'll do so up here because we want to know our random number before anything else goes on. And I'll go ahead and just clean this up as well. I'll do let super secret number is going to equal, and we need to import our random crate that we put into cargo.toml here, rand. So we're going to use rand, and we're going to import the RNG trait on rand. And again, we haven't gone over traits yet, but they're basically they add extra functionality to either a struct or an enum. It's just a way to add more methods if you want to think of it that way. So we're gonna then use the rand crate again. We're gonna call thread.rng to get an instance of thread RNG. And from that instance, we're going to call the genRange method. And we want 1 to 50 inclusive. And our inclusive range operators equals 50. And we're also going to print out this number just for debug purposes. And we're going to use debug here just because I don't feel like formatting with println. So super secret number. And we can just pass it in. We did just cover a couple new concepts here, so let's just check to make sure that everything's working well with cargo check. Always a good idea to do this as you're building your project to make sure you're not breaking something halfway through a large implementation. As you can see, we're more or less good to go. We're still working on this guest down here. So other than that, our check passed. So we need to read the user input. Now in order to do that, we're going to be importing the IO module from the standard library, standard crate IO, and we didn't need to import it into here because it comes baked in to the language. So in order to read the next line from our input, our standard in, we're going to call the IO module standard in, and then read line. And again, coming from a language where you manage memory, we want to pass in the guess pointer or a reference to guess to the read line function so that we can modify the contents of this guess. Or I guess that would be a method in this case. No, it's a function. No, it's a method. Just kidding. Huh. And we don't pass in guess by itself. If we do that, then we're effectively handing over ownership of the guess instance to read line. Ownership is a concept in Rust that you'll find yourself getting pretty familiar with, and it constrains how you can write programs and makes Rust as memory safe as it is. So to prevent memory leaks or mutate data in unexpected ways, there's a couple of rules that come to any data value in Rust. This includes strings, it includes integers, it includes our thread RNG instance right here. So rule number 1, and I'll put this I guess down here. Each value has an owner. In this case, that would be like saying let x equals 5. 5 is the owner, and 5 is the value. Rule number 2, there can be at most one owner to a value. In other words, no more than one pointer to a value in memory. That would be something like we're just going to do empty string at this point. So here, and again, this is outside of any code or the main function, so that's why we're getting nasty error messages here. But here and here, we are passing ownership to string 2 because no more than one variable can hold ownership to this empty string that we made. And that's the same with up here. So I can't do let guess2 equals guess. Well, I can do that, but then since there can only be one owner, then guess no longer references or owns anything, I should say. And we're going to go over this over the course of this crash course in detail. And then third, is that our values that are variables that hold ownership over a value, when the owner goes out of reference or the lifetime of this variable is done, then this piece of memory is then freed or no longer valued, and it's dereferenced. So that I could do something like, I have a scope here, let x equal 5, and of course that makes sense, right? 5 is no longer available down here, but it's available here. Okay, so that's the essentials of ownership in Rust. And again, these 3 rules are going to be, they seem more or less straightforward, but they're going to get pretty complicated when you start dealing with more complex logic. And just to drive this point home, I'll go ahead and delete this and show how we can't use guess anymore here because we passed ownership to guess2. So I'm going to comment this out right now and just debug guess2 cargo run. As you can see, it was moved. The borrow, or not a borrow, it's because we're not dealing with references, but an actual move occurred when we did this, and we tried using our guess variable here, which is no longer owns anything. Guess2 now owns this empty string. All right, now that we got that out of the way, let's go ahead and undo those lines and continue with our readLine method. We want a reference into readLine and not to pass ownership of guess into readLine. If we don't put an ampersand in front of a variable that we're using as a parameter into a function, a method, or what have you, then that means we're passing ownership of that variable into the function or method that we're using. So basically, we want to be able to use guess after we read into it, right? Or after we've read the standard into guess. We want to be able to use guess down here. Right now, if we do this, without an ampersand, without referencing it, we are saying, okay, give ownership of guess to read line. And then, like rule number 2 said, or rule number 3 is that when ownership goes out of scope, then this gets dereferenced. So since read line has a block of code, so here it's read line logic if we're looking inside the read line method itself, and then eventually we return. It could be return something, right? After this is done, then we don't have anything owning this string here anymore. So we got guess, got ownership of guess, and release ownership of guess since we're at the end of the function slash end of scope. We don't want to do that. What we want to do instead is borrow the value of guess. And that's what we use the ampersand for. That basically means get a pointer to guess, but in this case, a read-only pointer. We want to mutate the value of guess. In order to mutate a value of guess without giving up ownership, we're going to use ampersand MUT. So what this is doing is saying got a reference to guess, update guess, and since we don't have ownership of guess, we aren't stealing guess and then getting rid of it when we return. We can have as many immutable references as we want to a value, in other words, read only by this. Then in like another thread or somewhere else in our program, we can also have another some other function that is also reading in guess. We can do this as many times as we want. What we can only do once at a time is have this mutable reference to guess, because we're giving temporary permission to whatever function or method is getting a reference to guess to modify that value. And when we do have a mutable reference, we can't have any other reference to guess at the same time. Okay, last but not least for this line of code that we spent way too much time on, we're going to call dot expect failed to read line. My editor will work with me. The reason we did that is because read line returns a result enumerable. You can see here, result. The result kind of has the same concept as the option enumerable type that we were working with earlier. Except a result, as in there's two variants that the result type can have. It can either be okay, or error variants. And expect is a method that is baked into the result type, and we'll get into how that works exactly, but it's using this IMPL keyword in order to add logic into the enumerable. And expect works in the way expect basically says if we have an okay variant, we have either okay with some value or error with some value. If we got the OK variant, as in probably doing a match expression somewhere, then we get the value out of variant, so we get this sum value. If it's an error variant, then we quit the program. We're going to actually panic, and we'll get into panicking later, but it's going to panic with this message. So we failed to read the line. So we're unwrapping the value because result says, well, maybe this is going to work, but maybe we'll get an error. In the nutshell, that's what's happening. And if we get an error, basically we don't want to handle it. We're going to just panic and say, uh-oh, something went wrong. We failed to read the line, and that's going to be our error message. Okay, finally, at this point, we have the user's guess. We have read it into the guess variable, which is living in our heap. So let's print out the guess. And let's do our fancy format here with println guess. At this point, we should have the first part of our program set up. Let's check it out with cargo run. Oh, whoops. There we go. Cargo run. Please input your guess, and the secret number is 3, but let's put in 5. You guessed 5. Terrific. So that's a lot of new concepts that we introduced in this video. So let's take a breather, and I'll see you in the next video. I made a separate project just to really drive this point home because it is really important in Rust. So here we are dealing with a scalar value, and I inputted it to this scalar input function. And like the functions we were dealing with earlier, we didn't have to do a reference to x. So we're just passing in x by itself, right? And the reason why we're doing this is because x is a scalar value, or it's something that fits on the stack neatly. So we don't use a reference, and what's happening under the hood is that x is actually getting copied. So we're able to get a new copy of x down here. We could do let y equals x plus 3. And we have full control over this x that got passed into it because it's a copy of this one. And we can also print out the original copy if we want to down here. Now, this is where things get interesting. I'm going to reassign x, or shadow it, I should say, to hello as a string, not a string slice. And I'm passing x, I'm giving ownership of x to add to string. So now add to string is able to modify because I made it have to be mutable. Got a mutable string, I have ownership of it, added OK to it, debug. Now, if I try to do a debug down here of x, that's not going to work because we gave ownership of x, and x, my string, went out of scope after this function ended. So I'll go ahead and run this real quick to just prove that we can't run this. And our error message is use a moved value x. See, x got moved. Now if we did something like we got a mutable reference to my string, so in this case we're borrowing or getting temporary permission to write to my string. If we have a mutable reference to x instead of passing ownership, we'll go ahead and save here, and I'll make this a reference instead of actually sending it. Whoops. So we got our reference to my string. Now we want to dereference my string here. Dereference with a asterisk. dereference, and since it's mutable, we can do this and make sure that our original value is mutable. And we got to make sure we're passing a mutable reference as well. And we're going to get a lot more practice with this as we go on. But I'll go ahead. Hello, okay. As we can see, our program compiles and runs.